subject of discussion is reactions of benzene. Benzene undergo electrophilic substitution. Right. As the name indicates, it is substituted by an electrophile. Benzene, as we know, it is a 6-membered ring structure with double bonds in it and alternate double bonds at their positions. This benzene is represented in this fashion with molecular formula C6H6. These pi electrons undergo conjugation. They keep on moving from one position to other position, and that's why benzene is represented by both structure 1 and structure 2. Right. What it indicates? There is a pi electron cloud above and below the plane of the ring system, and that plane, this electron cloud, is represented as a ring inside a benzene ring. Benzene, though it has double bonds, but it do not undergo addition reaction. Addition reaction is the characteristic reaction of an alkene, a compound containing the double bond. But here, benzene do not undergo electrophilic this addition reaction. But instead of electrophilic addition reaction, it undergo electrophilic substitution reaction. Today's subject of discussion is the electrophilic substitution reaction of benzene. Benzene, what is this an electrophile? As the name indicates, electrophilic. Electron, philic means loving. Electron loving species is an electrophile. It is something like what we have, we won't like. What we don't have, we like. Electron loving means it do not have electrons. Here, electrophile, when it is electron loving means it is electron deficient. Electrophile is electron deficient species. This is, if it is electron deficient, it is represented as E plus. What are these electrophiles? NO2 plus is an electrophile. SO3 plus is an electrophile. Cl plus is an electrophile. Right. This is electron deficient. And in benzene, we have seen there are double bonds. Double bond means they are electron rich. Benzene is an electron rich species. Electrophile is an electron deficient species. That's why electron rich species react with electron deficient species, and thus a reaction occurs. The reactions which the benzene can undergo is electrophilic substitution reaction. There are various electrophilic substitution reactions which it undergoes. One among them is nitration. Benzene reacts with concentrated nitric acid in the presence of concentrated sulfuric acid to give rise to nitrobenzene. There are hydrogens here. Right? This hydrogen H plus is substituted by NO2 plus. To give nitrobenzene. H plus is replaced by NO2 plus. And this mixture of concentrated nitric acid and sulfuric acid is called as nitrating mixture. How this reaction occurs? Let us look into the mechanism of the reaction. Sulfuric acid, it can dissociate into H plus and HSO4 minus. As per Lowry's-Bronsted theory, an acid is a proton donor. Sulfuric acid is donating the proton. That's why it is an acid. How it can donate? By dissociating into H plus and HSO4 minus, and this H plus is donated by sulfuric acid. This H plus, which is formed reacts with nitric acid, OH, N double bond O, double bond O, HNO3. This has lone pair of electrons. This is electron deficient. This is electron rich. The lone pair of electrons combines with this an electrophile, and it gives rise to and protonates the OH. The protonation of the nitric acid occurs, and oxygen valency is 2, but it is bonded at 3. That's why this is electron deficient. This is electron deficient means it is unstable. To become stable, these electrons moves towards the oxygen to satisfy the positive center, and it gives rise to H2O. As these electrons are given away from nitrogen, what happens to nitrogen? It becomes electron deficient. It is a nitronium ion. Nitronium ion is the intermediate form. This is a electrophile. This reacts with benzene in double bond O plus. In the presence of an electrophile, the pi electrons moves towards one end, temporarily creating electron richness on this carbon because of the attraction of an electrophile, rendering this slightly positive. This electron rich carbon combines with NO2 plus. It gives rise to HNO2. A benzene carbocation is formed. To satisfy this positive center, these electrons moves once these electrons moves, the positive center gets satisfied, and as these electrons are moved, this becomes electron deficient. It is something like my neighbor has a problem, then I will help him. And when I help him, whatever money I have given to him. What happened to me? What happens to me? I am moneyless, deficient. To satisfy this positive center, these electrons moves and a new positive center at another carbon is formed. There is no another double bond pi electrons adjacent to it. That's a bond between carbon and nitrogen breaks. Electrons are donated to positive center to satisfy this positive center, and it moves away as H plus. Now I have got nitrobenzene. This H plus which is formed combines with HSO4 minus which is formed in the first reaction and gives rise to sulfuric acid. Whatever sulfuric acid I added, it has come out. Sulfuric acid is a catalyst. A catalyst is a species which do not involve in the reaction, but in its presence it hastens up the reaction process. It occurs in 3 steps. The first step is formation of proton. And the protonation of nitric acid takes place to give rise to nitronium ion is the second step. Nitronium ion which is formed attacks on the benzene ring and it replaces H plus. This is third step. Further, the H plus which is formed combines with HSO4 minus within the first step and gives back H2SO4. The NO2 plus has replaced H plus. This is to give nitrobenzene and this is nitration of benzene. This is an excellent example for electrophilic substitution reaction. Likewise, all other reactions in many other electrophilic substitution reaction occurs that will be the subject of discussion for the coming class. Thank you.